9-2 in advanced geometry. We're going to do some reflections and some dilations today. The hardest part about it is honestly like reading it. We learned last time that the lowercase r stood for reflection, and here they're asking me to like reflect point A, but they put this little subscript right here. That's a cursive L over line L. And what I want to do on this first one, which is not on your worksheet at all, right? I just want to like totally take some guesses before we measure things out and all that crazy stuff. Like if I want to reflect A over line L, what do you think about A prime going down there? Do you think that would be correct or incorrect? What do you think? Yes or no? Doesn't look right, right? Because if I connected those together, it's like, hey, this distance and this distance don't really look the same. Doesn't the pink one look a little too long for the green one? So what if I moved it a little closer? What if A prime, what if those were perfectly the same? Would that be good or still not good? What do you think? Good or not good? Where should this guy be? I think you get it. It should be like right here. Like, you know, to like totally be right there. Why does it have to be right there? Talk to a neighbor. What do you think about if I connected these together with a segment? What's true about this segment in relation to this line? Yeah, we got to vote for this angle right here should be perpendicular. How do you feel about that being 90 degrees? And what do you think about this distance in pink compared to this distance in green? What do you think? They should be the same. Like if this was 1 inch away from the line, shouldn't it be 1 inch away from the line on the opposite side of it? So that is the definition of reflection, which is definitely on your worksheet at the top. The hard part is writing it. I'm going to say it in English, but it's written in math. I'll scoot this up so you can see it a little better. It says, if the reflection of A over line L is A prime. Notice how it's written. If the reflection of A over line L is A prime. If the reflection of A over line L is A prime, then L is the perpendicular bisector of segment AA prime. Then L is the perpendicular bisector of segment AA prime. Just like you told me right here, like this guy's got to be 90 degrees for that to be reflected correctly, and this segment AA prime that I highlighted in green right there, like it is boom, boom, bisected as well. Line L, the line perpendicularly bisected that segment that was made up by those guys. So let's do some reflections with our geometer. If you are watching in video land, I need you to stop watching this video and go watch the other video that is posted on Canvas, because I took it with my phone so you can actually see how this is done, because with just a screenshot recording, there's no way you're going to be able to see how this is done. So please pause the video, watch that now, and then come back to this video. It's only 2 minutes long. So all right, so for us here in person, here's the thing. They ask us to reflect this triangle over line M. Bro, we're not going to reflect the entire triangle. We're just going to reflect the 3 points. So follow along with me. Could you take your geometer, and here's the very first move. Whatever line you're reflecting over, we got to extend it out very long. How long? All the way, man. Trust me on this, as long as your geometer is going to make it. So phase 1, extend that line out very much longer. So like I said, you watched that other video. We just realized that A was 1.6 units away, so we're going to call that A prime. Now let's do it for B, right? Let's reline everything up, put the black line right on top of the line you extended out longer, and get this thing all lined up with B in that case. The black line's got to be on top of there to keep you perpendicular. Once you've got those 3 vertices like reflected, you just take your straight edge and connect those together. And you'll get triangle A prime, B prime, C prime. Just join us on the next one. Just get us on the next one. A prime, B prime, C prime. Cool? Hey, last time we did it on a graph. What do you think? Should these be same size, same shape? What do you think? Should the pre-image, the original guy, be the same size, same shape as the image? Cool. Let's talk about some other stuff, big time test questions. They're going to ask you a lot about orientation. So first, it's like, what does orientation mean? It means like, which way around the clock are you going? Are you going clockwise or are you going counterclockwise? Hey, I know in 2025 not everybody understands how to read one of these old school clocks. Do you know that clockwise means going this way around, though? Are you cool with that? So clockwise, counterclockwise is the opposite way. So if I called this triangle ABC, like the original guy, and I just drew an arrow, please draw the same arrow with me, go from A to B to C, like because I went ABC. Hey, which way is that guy going? Clockwise or counterclockwise? So let's put counterclockwise, CCW, counterclockwise. Then they're going to say, well, how about, since I went ABC the first time, you have to go in the same order on the other one, but it's going to be primed. So how about A prime, B prime, C prime? Let's draw that. What do you think? A prime, B prime, C prime, is it clockwise or counterclockwise? Clockwise. So they're going to ask you this. What happened to orientation? Was orientation the same or reversed? It was reversed, and if you think about it, isn't a reflection just a flip it over kind of thing? So that makes perfect sense. It's like, oh, the orientation should be reversed because I just totally flipped this guy over. So that's a reflection. Let's do another one here. First, let's reflect this guy over line N. So let's make it long this time. It's cool that you go into other questions, right? If the line that you extended out longer goes into other questions, no big deal. Make it very, 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 very long. So take your straight edge, extend out line N. Don't go erasing that either. I grade that. If you don't extend the line, I can't give you credit for these because there's no way that you stayed perpendicular. Your thing's going to be off just a little bit. So let's just start. Put your black line on top of there and line them up with A and reflect A over. So A prime should be over there. I put them all up because people start freaking out. They're like, I don't think this is where B prime should be or where C prime should be, etc. So that way you can see it as you do it. Like, it's totally, totally going to be okay. The hardest part is putting your dot for your point versus your prime, which is like in a little apostrophe. So if you make them too similar, you'll get confused of how you connect these together. So I always try to make a big fat dot for my point and like a skinny little apostrophe for my prime. So everything should line up. You got A prime, B prime, C prime, D prime, F prime. And if they don't line up, you didn't have your line extended out long enough, or you mismeasured. Like if this was supposed to be 1.2 centimeters, you may have made that 1.7 centimeters or something like that. And you can tell that mine's not perfect either because doing this on a computer screen is definitely not an easy thing to do, right? So mine's not perfect in that matter. But what do you think? There are like 4 things preserved by every single reflection. It's called the ABCD postulate. And the reason why they call it the ABCD postulate is because those 4 things start with the letters A, B, C, D, and etc. So here's my first question. Let's pretend this was 30 degrees. You don't need to put that in your picture. But if that was 30 degrees, when I reflect it, what should that angle measure right there? 30 degrees. You know why? Because angle measure is preserved. Angle measure. Angle measure is preserved by every reflection. If the original guy is 30 degrees, the new guy is going to be 30 degrees. Talk to me about like this. When I highlight this dude right here in orange, is B between A and C? Yes or no? Yes? So when I do this new guy over here, do you think B prime should be between A prime and C prime? B stands for betweenness. Got to be spelled correctly also. B-E-T-W-E-E-N-N-E-S-S. Double the E, double the N, double the S. Betweenness is preserved. These are test questions, by the way. You'll see this 5,000 times between now and test day. What are 4 things preserved by every reflection? Angle measure, betweenness. C is the tough one. How do you feel about these 3 points right here? Did they all line up? Yes or no? Did they all line up? Starts with a C. What's that word that means they all line up? What? Collinear. Do you think A prime, B prime, C prime should be collinear? If A, B, and C are collinear, then shouldn't these be collinear also? So the C word is collinearity. It's the word collinear. Collinear with an I-T-Y at the end. Collinear, collinearity, collinearity. And then D, if this measured 2 inches, what do you think about this? How much should that measure right here? 2 inches. Take a wild guess what D stands for. the distance is preserved. Distance is preserved. The ABCDs, angle measure, betweenness, collinearity, and distance. Yes, they have to be spelled correctly for you to get credit on your test. And it's 100% a test question. It is also a quiz question as well when we take our quiz. So the ABCDs. Then those are called something special. Those are called an isometry. An isometry is a congruence transformation. That's all you got to put is what's in this pink box right here. A congruence transformation. If you preserve angle measure, betweenness, collinearity, and distance, you will stay the same size, same shape. You will be an isometry. Isometry. So let's talk about things we did on skill check today. We did reflections. Are reflections in isometry? Do they keep things same size, same shape? Yes or no? Yes. What about a translation? Is that an isometry? Will angle measure, betweenness, collinearity, and distance, aka will they be same size, same shape? Dilation. Is a dilation an isometry? No sirree, Bob. Cool. So let's do another one. In the picture at the right, what is the orientation of triangle XYZ? I would like you to draw an arrow for that. How do you connect them together? Go from X to Y to Z, baby. Let's draw this guy from X to Y to Z. What is the orientation of that guy? Counterclockwise, which you're always able to abbreviate. What would be the orientation of its reflection image? Clockwise. Don't even have to do it, right? It's just, it says what is not preserved by a reflection. That would be orientation. Orientation is not preserved. Reflections preserve angle measure, betweenness, collinearity, and distance, but they do not preserve the orientation of these guys. What do you think? Not too bad? Let's try again. Please, first of all, what does this say? I'll highlight, you say it. What is that? Draw what? The reflection, and then you just say the green thing of A, B, C, D, E over line AB. Please extend line AB out very much longer. And let's get one thing out of the way once we extend that thing out longer. They want us to reflect A, B, C, D, E over this line. Let's start with A. Where is A located in relation to the line we're trying to reflect over? It's on it, right? So somebody said 0 units away. Would you believe it is 0 units away from the line? Should we put an A prime? No. If the point is on the line, we don't have to reflect it. We don't get a new point. Is there any other points on the line? B. So your job is to reflect C, reflect D, and reflect E, right? Reflect those 3 points, and we will connect them together. So we just had to reflect C prime, or C, D, and E to get C prime, D prime, and E prime. And then even though I did this last time, I'm going to do it again. Way off, right? Way off. What did I do wrong? Did I reflect wrong, or did I connect wrong? Connecting the dots wrong, right? All my points are correct. My C prime, my D prime, my E prime are correct. But when you want to connect them together, if A is connected to E in the original, A's got to connect to E prime in the new guy in that case. So it's easy to do, man. It's easy to mess up. So make sure that we go boom to boom to boom to boom. Not too shabby, eh? Just doing a reflection. Definitely not a computer question, though. It is very pencil and paper-like. Yeah. I don't want to do this one because I just kind of have taken it off the homework, but let's see if you can read it and tell me what it would roughly look like. First, tell your neighbor what that means. Yep. And then let's just talk. Reflection of RQTS over, this is the name of the line, so what's the name of the line? Line C is going to be RWTY. Back here, they didn't like give me what it's supposed to reflect to, you know, So we just call them like primes. Here you don't make up primes for them. Like R is supposed to reflect to R, Q is supposed to reflect to W, T is supposed to reflect to T, and S is supposed to reflect to Y. Do you see how they go in like corresponding order? Hey, here's how we'll skip it. Could you tell your neighbor how that can happen? How would R reflect to R? If it reflects to itself, where's that bad boy got to be located? On the line. Is there any other points that are also on this line? Yes. T is on the line as well, because doesn't it reflect to itself in that case? So, cool. Let's skip that bad boy and go to the back side. Please do number 6. Extend the line out very much longer and get her done. The video. The whole reason that I put this question on here, because people used to freak out back in the day that like A and B are like on the left side of the line and C is on the right side of the line. It doesn't matter, right? It's like when you reflect, they'll go to the other side. So this is what she'll look like when you get there. B went to B prime, A went to A prime, and C went to C prime in that case. So. And then once you get those done, you can do 7 and 8 about the orientation. Orientation. I like to draw the arrow just of the original guy when they ask about orientation. What's the orientation of triangle ABC? It's like you have to go around the way they name it. You know, it's like, because you could call it CBA and it would reverse the orientation, like if they call the triangle CBA. But since they called it ABC, you got to go from A to B to C in that case. So whatever they name it, that's the order you go around in. And that bad boy is clockwise, which means that A prime, B prime, C prime should be reversed of that, of counterclockwise. Those are reflections. 4 things preserved: angle measure, betweenness, collinearity, and distance. What is not preserved by this guy? Orientation. The way you go around the clock is orientation. Feel okay with that? Again, we all make mistakes. It's usually a misreading of the ruler in that case. Last thing is dilations. So they ask us to dilate this guy around point C with a ruler. First, let's talk. Here's the scale factor. The scale factor is 2. What should happen with this guy? Should he get bigger or should he get smaller or should he stay the same size? Bigger by twice as much. One thing I forgot to put on here is letters. So to kind of stay consistent with what I got on the next slide, let's call this like ABC, which is a horrible thing for me to call that triangle ABC because it isn't the point where like dilating around also C. So shame on me, but I haven't fixed my slideshow. So if you were doing it different, you could call it XYZ or something. Don't use the same point twice. But to keep consistent with my slideshow, here's what I need you to do. Take your geometer and just connect like from C to A. And go through it, right? You know, do you see how I like to, we're not measuring anything right here. We're just connecting from C through A. Then what I need you to do is measure this guy. So like use the centimeters part of your ruler and like literally just put 0 on C and then measure how far it is to A. Obviously what this ruler says is going to be different than what is in real life. Also because I have blown this picture up to make it easier for you guys to see. Did you get 1.5 centimeters? Is that what you got? From C to A is 1.5 centimeters. But realize we're just measuring. You're starting at the 0 mark of your ruler and measuring how far is it to A. So all we got to do is grab ourselves a calculator. And since the scale factor is 2, would you believe the distance that we just had right there was 1.5? Just take it times 2. Some people can do that mentally since it's just to multiply by 2, but wouldn't that be 3 centimeters away? So your job is to put your straight edge, the 0 still on here, go to where 3 centimeters is and put yourself A prime there, right? If A is 1.5 centimeters away and we want to dilate it times 2, shouldn't A prime be 3 centimeters away? Doesn't that make pretty good sense? So then we'll do that again with B. Connect from C through B. And then just measure how far is it from C to B. Don't shout it out yet. Just give people a chance to measure. I got 2.5. Did you also get 2.5? Like I'm measuring from here to here, right? You know, does that kind of make sense? Did you get 2.5? Or very close to that, right? 2.4, 2.6, you know, it kind of depends. So just double it, right? Just double it. And then that would mean I would go to 5 and call that B prime. And then you do that one more time. And don't think that everything has to land on the 0.5s. You know, it's like A was 1.5, C was 2.5, or excuse me, that was B. C, I got 1.7. You know, it's like, so just double 1.7, and that would be 3.4. So you're just measuring from here to here. So then measure that guy out and call him C prime, and then just connect from A prime to B prime to C prime. And it should be the same shape. It's still a triangle, but it should be twice as big. Twice as big. Is that an isometry? Angle measure between this collinearity distance, was that preserved? No, because the distance thing, you know, the distance is definitely way off. And it's interesting about the angle measure. The angle measure should be the same because they're similar. So yeah, but not the distance. So are you cool with that? That got bigger. Let's try the next one. Scale factor of 1/4. What should happen? Should it get bigger or should it get smaller? Cool. Let's call this A, B, C, D. And then, hey, here's something that it's up to you. Check this out. Do you see how I connected those together and drew that line? I don't care if you draw that line, because all that does is just keep you lined up. Can you just like take your straight edge and actually just line them up, right? You know, starting at 0 here and just line them up and measure that. You know, it's like if you need to draw that line, draw that line. If you don't need to draw that line, who cares? What does it measure? Sorry, I wrote it down, but I walked away from my podium. What does that measure? 2.6-ish? Does that sound okay? So, like, can you just grab your calculator and take 2.6 times 1/4, which is also like 0.25, however you want to deal with it. Was it 2.6? Yes, it was 2.6 times 0.25. And I got 0.65. Well, that's not going to work for the tick marks, you know, so I have to round it to the nearest tenth. What do you think, 0.6 or 0.7? It's not going to matter. You're a half a millimeter off, you know what I mean? So it's either 0.6 or 0.7. Either one works. Does that kind of make sense? So it's not going to matter because we're in millimeters. It's so tiny. But it's up to you if you wanted to draw that line or not. So A prime, it got closer to C because this thing's supposed to get smaller. So you can do that again for B. If you wanted to draw that blue line and get them connected together, you can. If you don't, like you're going to see on my homework that I didn't draw those lines because it honestly starts making a mess of things. So it's up to you. If you want to draw the line, don't do or don't. But I got 4.2. So if you take 4.2 times 0.25, I got 1.05. So I would go to 1.1. You know, just rounding it to the nearest 10. So 1.1. And there's B prime. And then you can do that again for the C and the D. Doesn't matter what order you go in either. Like, it's all got to get done. It's interesting that you could use the same line both times, you know, because those are all collinear. So if you're drawing the lines, you don't need to draw it twice. But I got 1.5 for D. I heard somebody else say they got 1.6. It's all good in the neighborhood, right? We're just a little bit off, human error. The thing is, you're taking it times 0.25, and then I would call that 0.4, you know. So we're just rounding to the nearest tenth of a centimeter, which is called a millimeter. The interesting thing is if you were not calling it 1.5 and you were calling it 15, it's like, well, I got like 15 tick marks. Fine. If you're calling it 15, then when you multiply it out, you know, you'd have to realize that you'd get 3.75, so you'd have to go to 4 tick marks. I like to do it in centimeters. But they should be the same shape, just different sizes. And that guy right there got 4 times smaller. 4 times smaller. Got dilated by 1/4. And if you got that right, there's just one left. What's fascinating is that the point that you're dilating around is a part of this object, right? So just see how that affects it. Maybe call the other letters like A, B, C, and A, B, and D. It doesn't matter which one's which when you're doing homework. Hopefully they have letters on there, but I like to just label them so you can see which ones you're moving, you know. Which one am I moving? How do I connect these back together? So give that guy a shot. I'll do D first. You just like connect from C through D or line it up with your straight edge and just measure how far it is. And you take it times 5/4. I didn't measure it. Could you tell me how far that is? What was it? 2.9. So 2.9. If you want to take it times 5/4, you like put that in parentheses, 5 divided by 4 if you have a graphing calculator, or you could calculate it to be 1.25. Like some of the scale factors don't come out as nice, neat decimals, you know. So like if that was like 2/3, you know, you'd have to use the 2/3, you know, like by putting it in parentheses and stuff. So, but bam, and then it's going to get bigger. Like 5/4 is bigger than 1. So there's where D prime went. And then you can do that for the others. Don't care if you draw the green line or not. Need the D prime, need the A prime, need the B prime. And how far would C move? C would not move, right? It is 0 units away from itself, right? So it does not move. So you just connect those together. Yes, you go back to C, though. It's like, is C a part of this? It sure is, you know. C is a part of the new guy. So you connect those bad boys together. And I'll highlight him in orange. That got bigger by a scale factor of 5/4, a.k.a. 1.25. Man, let me know if you have any questions, right? Please make sure you've also watched that other video about how to do the reflections, because it makes no sense trying to do it with just screenshots. So have a good one.